water scarcity affects at least 11% of the population and 17% of the territory in Europe, especially in areas with low rainfall and high population and with intense agricultural, industrial or tourism activities. The industrial sector is the second largest consumer of water after agriculture, using 22% of the freshwater resources drawn in the world. And within it, the petrochemical industry is the largest water user, generating annually 1,750 hm3 of wastewater in Europe. In order to decrease freshwater consumption, some petrochemical plants have started using reclaimed water from urban wastewater treatment plants. However, the industry needs to be close to an urban WWTP to meet both cost efficiency and sustainable criteria. In this sense, the project Rewatch, funded by the European Union through its LIFE program, proposes an innovative water reuse system based on 5 different technologies to constitute a completely new treatment strategy in the petrochemical industry. The main stages of the Rewatch water reuse scheme include the collection of wastewater generated in the petrochemical industry, a physico-chemical pre-treatment aimed at removing mainly suspended particles, a biological process which eliminates organic matter, nitrogen and phosphorus, a process of ultrafiltration aimed at eliminating solids previously to the next filtration step, the reverse osmosis, a high-pressure filtration method aimed at removing dissolved salts, the water deionization, which removes trace metals and salts by an ion exchange process using resins, and finally the use of reclaimed water by the same petrochemical industry as boiler feed water and cooling tower makeup. This highly versatile treatment scheme will be tested in the North Petrochemical Complex of Dow Chemical Iberica, located in Tarragona, Catalonia region. This area is an example of a water-stressed region with a high water demand by the touristic sector during the summer months. The benefits that the project Rewatch brings are significant reduction both in freshwater consumption and wastewater discharge of the industrial sector, climate change reduction due to energy savings related to the water cycle, support future water reuse standards and policies at national, regional and European levels, educating and making citizens aware of the environmental problems caused by an increase in water consumption. After 3 years, the project comes to an end with the prototype operation demonstration. In the following footage, you will be able to see by first hand how the pilot plant works. The feed water is collected from Dow's cracker different wastewater trenches and is sent to Veolia's treatment system, starting with the coalescent filter where non-emulsified oils are separated from the mixed wastewater stream. The water goes from the coalescent filter to the Anox coldness MBBR, where the biological treatment occurs in order to remove the organic content. After the MBBR, the water is conducted to the ActiFlow system, where different chemicals are dosed to separate the biological matter from the wastewater stream. Suspended solids are removed thanks to a ballasted flocculation process. The outlet of the ActiFlow is the inlet to DuPont's system, where water is directed to the ultrafiltration modules, passing before through a ring filter. The ultrafiltrate water, free of suspended solids and turbidity, is collected in the reverse osmosis feed tank, and from there, it is pumped to the RO system thanks to the high-pressure pump. The permeate produced in the RO system has a purity degree that could be used as cooling tower water. This permeate water produced in the RO system is directed to the last step, feeding the ion exchange resins, ionic and cationic resins, where a very high water quality is produced, which could be used as boiler feed water. Configuration could also allow to operate having IER between UF and RO to increase the robustness of the process. All the treated water and reject streams are returned to Dow's cracker trench system, as it is a demonstration project. However, the results of the project could be applied in real industrial installations.